All right, boys and girls. Today, during science class, we are going to be completing a simulation experiment that entails measuring the state of matter in given atoms and molecules. But before we begin, I am going to refresh your memory on the material that we learned from class last week. We learned that there are three states of matter. There are solids, liquids, and gases. We learned that solids are molecules held together by strong bonds and that they can keep their own shape and size. We learned that liquids are molecules that have weaker bonds and that they can't keep their shape unless they're in a container. And lastly, we learned that gases are molecules that are free to move around and that they can't keep their shape unless they're in a sealed container. Now it is time to begin our simulation experiment. Throughout this simulation, we will be periodically changing the temperature and pressure of neon, argon, oxygen, and water to measure the adverse effects that this places on the state of matter. We will also be using a phase diagram to check and see if our findings are accurate. First off, we are going to be adding pressure to our neon molecules. As you can see right now, they are at a solid. And as pressure is added, these molecules they spread apart and they transform to a liquid and then to a gas. And you can see that these are very weak bonds and that they're far apart from each other, moving fast. Now if we add some cooling to our neon molecules, let's see what happens. Right now they're at a gas state of matter. As cooling is added, you can see that these bonds are forming closer together. They're at the critical point right now, reaching to a solid, which is at the triple point. And if we did the complete opposite and added heat, they would reciprocate by doing the complete opposite. Now let's test argon. Let's add some pressure to argon. They're currently at a solid state of matter. And as pressure is added, they're at a liquid now. These molecules are spreading apart. These bonds are breaking up. And now they're at a gas. And if we add some cooling to our argon, let's see what happens. The temperature is currently dropping right now. It takes a little while. And you can see now that these bonds are forming closer together. They're at a liquid right now, the critical point. And now they are reaching to the triple point. Let's test out oxygen. Our oxygen molecules are currently at a solid state of matter. And as we add pressure, these bonds break up and they form into liquids and then gases. If we were to add some cooling, let's see what would happen. These oxygen molecules are currently at a gas state of matter. It takes a little while for the temperature to drop. And soon enough, they're going to form into a liquid and then a solid. There we go. You can see that these bonds are coming closer together. They're becoming stronger bonds. And now this is a very strong bond. Now let's test out water. Let's add some pressure to our water molecules. They're currently at a solid state of matter. And when we add pressure, they transform to a liquid state of matter. You can see these molecules are spreading apart. If I add more pressure, then they transform to a gas state of matter. And you can see that these molecules are very spread apart and they're moving fast. And we can actually pause it. This is a very cool feature. We can go in slow-mo and see that they're a gas. And then if I were to add heat, they would not transform. They would continue to stay at a gas. But if I were to cool this, then these molecules would transform. They would spread apart. They're at a critical point right now, the liquid, and they're now at the triple point, which is the solid. And if I were to add heat, they would do the complete opposite, and they would spread apart. And that wraps up our lesson for today. Great job, boys and girls. We are now about to take an assessment.